Okay, so welcome to our Unity workshop. This is the second workshop from the ACM, but this one is going to start our series. The last one was a standalone lecture, but starting with this one, we are going to be continuing on the game that we start tonight on to, several more workshops. And again, they're every other week on Wednesdays in this room at this time, 6 o'clock to 10. So we asked on the CS West Florida Discord what kind of games people would be interested in learning to program, and an overwhelming amount of people said that they wanted to learn how to make a platformer. So that is what we are going to do today, or we're going to start making a platformer. So if you're new to Unity or you don't have Unity installed, unfortunately, it takes a very long time to install. So we don't really have time to make sure everybody has it installed. But if you do have it installed, then you'll want to go to Unity Hub and create a new project. And we are going to be making our platformer 2D. So select 2D. And name it anything you want. I'm going to call it Unity Workshop 2. We're going to create that, and it'll go through the process of starting it up. This sometimes takes a little while, so if you're following along, it might take your computer a few minutes to get this all up. In the meantime, so we are going to create a stage for our character to run around on. We're going to create a character. We're going to make it so that when your character dies in game, they respawn at the beginning of the level. And if we have time, we're going to add a sprite to our character. But that's just going to be a little bonus. We're going to go much more in depth in how to do it later on, but if we have time, I'll go ahead and show how to do that. But yeah, so we just gotta wait until this all starts up. It's reasonably fast. It has dedicated graphics, so I don't know the exact specs of it. It's not because it's not mine, but if it tells you that there's a Unity update, you can just go ahead and X out of that, because usually or at least in our experience lately, that's been like a development build and it's not the stable build. Anyway, so this is the Unity editor. From here, it does a lot of interesting things for you and you don't need, and a lot of things are abstracted away from the code, so you don't have to worry about programming every single little aspect of the game. So over here, this is our scene. This is where we put objects that will be on in the game at any given time. This is our game menu. Anything surrounded by this white box here will be on the camera right when it starts. And then this is our assets folder, where we keep files that are necessary for the editor. And then over here is our inspector, and the inspector is where we're going to be editing things like values for objects that we add into our game. So is everybody who's following along? Do you have the editor up? Okay. We'll give it a few minutes. But yeah, so basically the main workflow of this is that you're going to create an object, and then you're going to give that object properties like the ability for it to be affected by gravity, or the ability for it to collide with other objects. And then to supplement that, you add in code, which generally the code in a Unity project is how it interfaces with the player. So it's the human interaction portion of it. Code in this is in the form of a script, and scripts are added to objects. Yes?
While you guys are also
Whichever editor you have.
Yeah, whatever editor. Whatever editor.
Okay, how's everybody doing? Good. Everybody who's following it along, do you have it up now? Okay. I'm just gonna move things around a little bit. Like I said, this is going to be our window. This is going to show us what's going on at any given time. You can start the game by clicking this this arrow up here, and you can pause it or stop it by clicking the arrow again once the game is started. If I start it right now, it's just going to be an empty screen because obviously we haven't added anything to it yet. And I believe if we wanted to, we can change the color of the background, you know, and change it to purple. That's my favorite color. I don't know about you guys. If you do that, then we now have a purple background. And that's how you're mostly going to be interfacing with the things that we add into the editor. You'll click on it in the hierarchy here under your scene, and then in the inspector you have a whole lot of options that you can use, and then you can add components to it in order to add more things like scripts and colliders and stuff like that. Okay, so I'm going to go ahead and create a couple folders for the things that we're going to be adding. So I'm gonna go into the assets folder down here at the bottom, and I'm going to create a folder, and I'm gonna call this one scripts. We'll just put any scripts that we write into that folder, and then I will create another folder, and we'll call it sprites. So as I said, scripts are code. In Unity, we code in C#, which is almost like Java. C# is Microsoft's answer to Java. And then, so it's an object-oriented language. And then sprites are like objects that are on screen that, you know, show up. So an example of a sprite would be like your the image that represents your character as you move along. Later on, there's, you know, you can animate sprites so that as you walk, you know, it'll change the image to make it look like they're walking. But we are probably not going to get to that tonight. Okay, so I'm gonna go ahead and start making some sprites. So we'll go into our sprites folder. You can double click on it, and gonna create. And under create, you have lots of different options for things that you can make. But we're going to go under sprites, and we're going to make a square. And this square is going to be our character. So I'm going to call it player. Now we have this sprite, and we have a file that's representing this sprite, but it's not in our game yet. In order to place it in our game, we need to move it from the sprites folder down here up into the hierarchy. And so it's now in our game, and we can move it around, and we can change its size, make it big or small, but we're just going to make it about that size. That looks good to me. Our character is going to be a brave little cube, because, you know, there's a little bit more to making characters that aren't just like squares, you know. And so the other major sprite that we're going to need for this for tonight is we're going to create another square. And this one is going to represent our stage. This is going to be the ground that our character walks on. So I'm going to call it stage. And then again, in order to have this in our game, we need to move it from the sprites folder into the hierarchy folder. So now we have this here, but you know, this isn't much room for your character to walk on. So what we're going to do is we're going to move it down to about where we want it on the screen. I'm going to say about there. And then you can resize it. So I'm going to resize it to about that big. That way, you know, your character has a little bit of room to walk on, and you know, and room to jump off if he or she chooses to. And again, you know, you can go into the inspector and you can edit all the things. If you really want to, you can, instead of using like the resize tool, you can go ahead and set exact scaling here. You can do the position on the screen, the rotation of it, and the scale. So what we were changing when I did use the resize tool is the scale. And that's why we have like all these funky numbers, decimal points, you know, because it's not exact. And then in the sprite renderer, we can again change the color if we want. I'm actually just going to leave this one white, but I might change the character to maybe red. Okay, so we have that. How's everybody doing? Is there any confusion? Are there any questions? Everybody good? Okay, so what do you think will happen if I hit play? Do you think the character will fall on top of the stage, or the stage will fall? What do you think? That's exactly correct. Nothing is going to move because we haven't told it to do anything yet. They're just static objects on the screen. So you know, you can hit the arrow keys and everything, but that character isn't moving. So the next thing we want to do is we want to make it so that our character falls. So our character is going to be affected by gravity. We want them to be able to fall right down from where they are to, you know, wherever they can land on. So the way you do that is you go and you press add component. Now there's a lot of different components that you can add onto here. But we want to focus on only the ones that are 2D. So specifically, the thing we want is called a rigid body 2D. Now, what the rigid body 2D is it is a component that allows an object to have physics. And specifically, the 2D version of it will only allow it to have 2D physics. So, you know, up, down, left, right, stuff like that. So as you can see, we have added it to our inspector here under the player. So when I was already on the player in the hierarchy when I pressed add component, so that automatically got added to the player. So we now have this rigid body here, and as you can see, the gravity scale is 1. That means gravity will affect the player exactly 1 time, and we will change it from discrete to continuous. That just makes things more smooth, and that's pretty much all you have to do with rigid body. So if we press play, we'll see the character falls, but where'd he go? He went right off screen. He went right through the platform because the platform doesn't have anything to stop him. And so, what we did was we set collision detection to continuous, and gravity scale was by default 1. So now we got to make it so that the character knows when he hits a platform. So the way you do that is you add a collider. And so what a collider is like I said, it allows it to know when it has touched another object, and you can change what it does when it touches that object, but what we want is we want it to stop the player. So under the player in the hierarchy, we're going to press add component, and we're going to do box collider. So the character is a square, so we're going to use a box collider, so it'll fit to the edges of the character. So we're going to use box collider 2D. Now, this will allow the character to interface with other objects. We don't need to change anything here. This is just by default, it'll do what we want it to do, because all we want it to do is just stop when it hits another object. So we're good, right? Let's press play and see what happens. What? Oh, right off screen. So why do you think that happened? That is correct. So now the player knows when it touches another object, but the platform does not. So we need to add a collider to the stage. So if you click stage, then we now have the stage in our inspector. You can tell because it's still white. Like all these different things, you can tell which one you're on by, the name. It's highlighted in the hierarchy, and each one I made a different color, so you can also tell by that. So what we need is a box collider again. So we need exactly this. We need to do the exact same thing that we did to the player to the platform in order to stop the player when he hits the platform. So we'll add a box collider 2D, and again we will just keep it completely default because we don't have any special effect we want to happen when we touch that platform. So I hit play, and there we go. Our character is finally going to survive more than 3 seconds because he now has some firm ground to stand on. Hey Alex, I think the screen is getting tinted. Do you have like a program that's tinting the screen, like a blue light filter or something? Oh, weird.
Whenever you hit play, full screen.
Oh, is that what it does? Okay.
The important thing, do anything in play mode, on a key out of play mode.
Okay, so let's hit play again and let's see what's going on. So the player falls and he lands on the platform. So why does the player fall but the platform doesn't? Exactly. Rigid body is what allows it to have physics. It's the collider that we added to the platform. So only the character has a rigid body, and therefore the platform will not have any physics. So now we have our character. We have a platform. He has some place to walk. But now I'm hitting the keys, and he's not moving. So what do we do to make him move? We need to give him a script so he knows what to do when you hit the keys. So let's go back to our assets folder. So I just went up one directory, back to the directory before I went into the sprites, and then I'm going to go into our scripts folder. So you go into here, and we'll right click and create a new C# script. So this script is going to be what controls the player. So I'm going to call it player controller. Okay, so we now have our player controller script, and if you double click on it, it will open it in whatever editor you have configured. For us, it's going to be Visual Studio Code, but you might have another one, or VS Community. Let's see. Okay, so is everybody who wants to follow along here, or are there any questions up to this point?
Which library?
I am not sure.
regular website.
So what he said is that when you install Unity, it should configure the correct syntax completion. What do you call that? IntelliSense for you. But if not, it doesn't really matter for tonight because we're going to keep the code very simple tonight. For those of you here, I know it's really hard to see. We're going to try and figure out a better way to do this next time. But the entire code base of what we're going to be doing right now is being projected over there onto that whiteboard. But otherwise, it's only about 4 or 5 lines of code right now. So we're just gonna go nice and slow. So here in our player controller, we have a class player controller, and we have 2 methods. The methods being start and update. So if you look at the comment here, start is called before the game, as the game is starting, before the first frame. So anything that you want to initialize, that's basically the constructor for this class, start. Before it starts up, anything that's in start will run. On the contrary, update is called once every single frame of the game. So it's like a loop. For every frame that runs, it'll run everything in update. But that's not quite a really good way to do it, because think about this. Not every computer is the same speed. Some computers run things really fast, and older computers may run things a little slower. So if you go by frame rate, then the game might be a totally different experience for people who are running on a faster computer than it is people run on a slower computer. So what you do is you change update to fixed update. And basically what that does is it takes into account the time that the game has been running in order to decide how much should happen in a given time, instead of checking based on the frames. So I'm going to get rid of this comment because it is no longer accurate. So basically, now every update to the game, this will run. So let's see. There's a couple things we need to do. So we made a rigid body, and the rigid body is what we want to be controlling, because that is the physics of our character. So we're going to go up here and we're going to create a global variable. So you make global variables outside of any methods that shows that they're global, but inside the class. So what we're going to do is we're going to make a private. Private being, can only be accessed from inside this file. Rigid body 2D. That the B in body, rigid body is one word, so the B in body is going to be lowercase. That tripped me up the first time I did this. And we're just going to call it RGDB for just a shortening of rigid body. RGD rigid B body. So we're going to create that. But now we got to tell it what rigid body. This isn't initialized. It doesn't know which rigid body we're trying to call, because in a big game we might have 20, 30 of them on screen at once. So when we're setting up, before we start the game, we want to clarify which one we're talking about. So we're going to do that by calling rigid body, RGDB, our rigid body, and we are going to do rigid body equals get component. So get the component from the editor. Then we're going to tell it what kind of component we're looking for, which is a rigid body 2D. And since we only have one, it'll find the rigid body that we have in the editor, and it will connect it to RGDB. So that's going to be important. We now have a direct connection between the code and the editor. So with this, we'll be able to control the character. So now we want our character to be able to stretch his legs and move around, metaphorically, because he doesn't have legs. But we want him to be able to move. So what we're going to do is we're going to create a variable, float move, and float move is going to tell it which axis we want it to move on. So we need to specify that we want input input dot get axis, and then the axis that we want him to be able to move on is horizontal. So we'll specify a string horizontal. Now, if many of you may, I don't know how far many of you are in programming, but generally you would think that when you're doing something like this and you're specifying something to a method, you would use an enum. But the reason why we're using a string to specify horizontal is because later on there are options that allow you to create your own. And so a pre-specified enum isn't going to cut it. But that doesn't matter for right now. Basically, all you need to know is that input.getAxis is going to look for an axis named horizontal, and it's going to set that to move, which is our float variable. So now we have the axis, and we have the ability to get the input. Now we want to let our character receive that input. Yes?
What is an
So an axis would be like I'd write it on this board, but I don't have a dry erase marker on me. But it's basically the axis would be like left and right. The x, positive x and negative x to go horizontal, positive y and negative y to go up and down, or to go with depth you would use positive z and negative z. So I think you could call that a vector. Yes. Okay, thank you. So this would be our vertical vector, or this will be our vertical axis, and then this will be our horizontal axis, and then usually we denote it by going diagonal. This would be our depth axis, which we use Z for. This would be going inwards or outwards. But since we're doing a 2D game, we don't do very much of that. Like I said, we now have the axis and we have the input. Now we just need to move the character based on the input. So what we're going to do is we're going to specify our character, which in our code we refer to as RGDB, rigid body. RGDB. Sorry, I haven't typed much on this keyboard. Dot velocity. Velocity being the speed and direction that we want it to go. Equals a new vector2. So remember, I was talking, these are vectors. A vector is, like the direction and speed that you want. And we're going to say we want that to be move, which is our float variable that we defined on the previous line, times, we're going to say 5f, which is going to be our speed. And then we're also going to add in, so that is our how we want them to move on the x-axis. And so the next parameter is how we want them to move on the y-axis, but we're not doing the y-axis right now, so we're just going to do our character rigid body dot velocity dot y. So just whatever the velocity of our rigid body is at this very moment. So what this will do is this will allow the character to move when we click buttons that tell it to move, the arrow keys that tell it to move on the horizontal axis. But right now, what we're doing is we're multiplying this 5f, and that was just a value that I made up. That is going to be the speed at which we want them to move. But it would be a real hassle to go back into the code every single time we wanted to make a small change to how fast the character moves. So Unity has something built in for that. So what we're gonna do is we're going to create another global variable, and this one is going to be of a Unity type called serialized field. So that is serialized, not serialized, just serialize field. So serialize field. So basically, what a serialized field is it takes the value that you give it and allows you to dynamically change it from inside the editor. So we want our serialized field to be a float, so a decimal value. This is so that, like, later on, if we wanted to like add controller support instead of just clicking arrow keys on a keyboard, then if you tilted the joystick just a little bit, it wouldn't move one full unit, it would just move a little bit. So we use a float for that, and we'll call our float max speed. And we'll just replace the speed that I put in down here. We'll call it 5f just to start. So now down here, you can take out this 5f and just say move times max speed. So now, when your character rigid body moves, its movement will be multiplied by its max speed, which will allow it to decide how fast the character is moving. Yes? 5f means 5, the integer 5 cast to a float. So a float, is, dependent on how far you are in programming, I'm sure most of you know this, but a float is a decimal value. That's what we call decimal values in most programming languages, or just computers in general. And so we're just saying, take this number 5 and change it into a float. This could be 5.65, any decimal value you want, but we're just going to leave it at 5 for now. So now you have everything going here. You have your max speed, which, like I said, because it's a serialized field, we'll be able to change it inside the editor. And then before the game starts, or before the first frame, we get our character and connect him to the code. And then at every single update, it'll check if you're pressing down a button to tell him to move, and if you are, it'll move him at the speed at which you specified in max speed. So once you're done with that, hit Control-S to save everything. Nothing will work if you don't save. You can also go up to File and hit Save. Yeah, you can go up to File and hit Save if you want, but Control-S works just fine. And we will go back to our editor. So now we can go ahead and hit play. And now I'm hitting the arrow keys, but he's not moving. Why is that? Well, oh, go ahead. On some types of input you would, but the reason why it's not moving at all is because this player controller script isn't connected to anything. We haven't added it to the player. When Unity goes in and checks what's going on, it doesn't know where any of this code is running, so it just doesn't do anything. So what you do to fix that is you click on it and you drag it and you drop it right on top of player. So now if you click player and go in, you can see at the bottom here you have your player controller, and here's that serialized field that we were talking about. Now I can edit the speed of the character at any time right from the editor. So now let's hit play, and if I hit left and right, look, our character's moving. Great. And say, man, that's a little too slow for me, so I'm just gonna move this up to 10. I can go in and he'll move a lot faster. Huh? Yes, but since we're in play mode, if I stop the game, then it will go back to 5. Because you have to be out of play mode in order to make changes to anything. Are there any questions so far? Serialized field allows it to be controlled from here. If it was public, it would be able to be accessed from other fields in the same package, but it would be able to be accessed by other fields by other scripts in the same package, but it wouldn't show up under the controller in the editor. So if you've taken like intermediate programming, you've probably worked with like Java programs that are multi-file programs, and like if you have two source codes in the same folder, you can access the methods from the other one, or the objects, whatever you want to do. That's what public would do in this case. It's exactly the same, but serialized field is special in that it adds it to the editor. Let's see. So what's next? So let's give our character a little spin. So he's walking along, and he comes to the edge, and he falls right off. Now what? Nothing happens. The game's over, apparently. Yep, he's gone. But more notably, if you go to the edge of the screen, and then you fall off, and then you catch it and hold on, he just sticks. And he'll stay there forever until I lift the key, because the character isn't moving under his own power. It's moving as if you were pushing it. So if this eraser here is our character, it's not moving by its own. An invisible force is pushing it like this along. So if I push this against the table, it's not going to fall. And the way that you fix that is you change the physics of the platform. So right now the platform has friction, and the friction is what's allowing it to stay stuck when the character pushes against it. Are there any questions so far? Yes, go ahead and post the first code on the Discord. For those watching on the stream, if you are on the CS West Florida Discord right now, you can find the source code that we've written thus far on the Discord for the ACM. So the next thing we need to do is we need to change the physics of the platform. So the platform has a little too much friction for our liking. We don't want our character to be able to hold on to the edge when he falls off, You can't let the game be too easy. So what we're going to do is we have this, let's see. Under the 2D box collider, we have this field called material. Now, what material is it basically defines the properties of the material that the platform is made out of. So, like, ice is very slippery. It has very little friction. But like, say this table, it has quite a bit of friction. You feel it as you slide your hand across it. And so we want our platform to be more like ice and less like that table. So what we're going to do is we're going to change the material that the platform is made out of. So we're going to go back to our assets folder. We don't really have an assets folder. We don't really have a directory in here that would hold something like a physics material, but we're just going to place it right in the assets folder. So if you right click here, and you can create a new, and what we want is a physics material. Let's see, it's somewhere in here. Physics material 2D. Since anytime you're looking for a component, it's almost always going to be 2D, because we're making a 2D game. So now we have this physics material. I'm not going to name it anything. You know, it's just a very simple thing. But by default, and this is the default material that objects in Unity are made out of, it has a friction value of 0.4 and a bounciness of 0. So if we go into our player, not our player, I'm sorry. If we go into our stage, we want to change the material of this platform. So we're going to take this physics material, and you don't need to drag it into the hierarchy. You can drag it right on top of the material field here. And now and by doing that, our platform is now made out of this material. So now we can change the values of it. So we now, so say we wanted to lower the friction. We're going to put a friction of 0. So now, when the character goes to the edge, well, that didn't work. Maybe, I don't think, yeah, okay. I don't think you can change physics materials mid-game. But let me, so back again at this, you can just click on the physics material to edit it. It's now 0 and 0. So 0 friction, 0 bounciness. So now it should work. Yep, can't grab onto the side anymore. We just made the Dark Souls of platformer games, I guess. But yep, no stopping it anymore. And you can do other sorts of interesting things with this. We can change the bounciness. If we make it a bounciness of 1, that means the platform will exert the same amount of force that you put into it back onto the character in the upwards direction. So if you have a bounciness of 1, then he's just going to bounce the exact same height every single time. So you can imagine if you put it up to, say, 2, every time he hits the ground, he's going to bounce just a little bit higher. Or, well, twice as high, actually. And it'll speed up and keep going like that. And, you know, there's no non-bouncy platform, so he doesn't have anywhere to land. But that's not very fun. It's not very fun if you can never see your character. So we're gonna put the bounciness back down to 0. So now we have our character. He's not bouncing anymore, and he can't grab onto the platforms. Great. Okay, so now the next thing. When our character goes and he falls off of this platform, the game's over. There's nothing more that we can do. You know, you can't tell him to come back up. You can't move him anymore. He's just falling forever down into the infinite void. So we want to make it so that every time the character falls off, he goes back to the beginning of the level. So what we're going to do is we're going to create a collider that's off screen, and when he hits that collider, he's going to teleport back up to the beginning of the level. So the way that we're going to do that is we're going to go straight into our sample scene here in the hierarchy, because we're going to create something called an empty object. Now, what an empty object is it is an object that has no properties. It doesn't do anything. It's literally just there. You can't even see it. It's invisible. And we're going to rename it. Let's see. I'm going to call it boundary, since this is going to be our boundary to the level. If the character crosses the boundary, then it gets sent right back to the beginning of the level. Now, like I said, you can't interact with this thing at all. It's not here. It's empty. There's nothing to it. So what we need is to give it a collider, because that's what it's going to do. It's going to check if the character collides with it. So we're going to give it our box collider, but this time we are going to add some options into this. Specifically, we're going to hit this is trigger button. Now, basically, what that means is if it is trigger, sorry, if it is trigger, then the character will go through it. It won't stop the character, but it will send a message every time the character touches it. So we said we wanted this to be off of the screen. So it's hard to move these guys around. If you look up here, you have a bunch of tools that you can use, and these are mapped to your top row of keys. So this one will be Q, W, E, R, T, Y, U. Or, well, this one isn't U, sorry. But what we need is the move tool, which is the second one. So we want to move it. We want to move it off the screen because we don't want to be able to see it. And then we want to scale it, because there's a lot more room. He might just, if we leave it like this, he's almost certainly just going to miss it when he falls. He's just going to go right through. It'll never trigger, and nothing will ever happen. So what we're going to do is we're going to scale it up so it's real big. And I did that using the scale tool, which is the fourth one mapped to R. And so I'm going to go back to the move tool and click on it, and this is where it is now. Oh. So I'm going to drag it around a little bit. We want it to be a little bit bigger than the stage, because the character, because if this is our stage and the character is here and the box only goes like maybe this far, just a little past the end of the stage, he might just go right past it, So we want it to be a little bigger than the stage. In this case, we made it quite bigger than the stage. And now that we have that there, we need to tell it what to do when the character touches it. So the way you do that is you want to create a tag. So on boundary, our box collider that we have down there, up in the top corner here, we have something called tag, and currently it's untagged. Now these are a bunch of tags that do different things, or rather, they don't do anything. But we can check if it has. We can check if something has a property of that tag. So what we're going to do is we're going to add our own tag. So what you do is you go under tag and press add tag. And now we have this. It says the list is empty. You can click this little plus button here, and when you click that, it'll prompt you to create a new tag. So we're just gonna name the tag kill. So when the character has touched that boundary, he's dead. He needs to respawn at the beginning of the level. So if the character touches it, it gains the tag kill, and it needs to be moved. So we now have our boundary, and whenever anything touches it, it will trigger the tag to be used. So now we can go ahead and play it. Oh, my apologies. We have our boundary, and we will set it to our new tag that we just made here. So now we can go ahead and play, and we'll just go right on through. Oh, what the heck? Nothing happened. Okay. Well, that's because the tag doesn't do anything by itself. We need to tell it what to do. So this is where our second code segment is going to come in. And this one is, I believe, even shorter than the other one. Alex, would you mind posting the second one to the Discord? The second set of code will be posted on the UWFA the CS West Florida ACM Discord right now. But since we're handling something that is going to happen to the player, we're going to add it to the player controller. So we'll go back to our scripts and we'll open the player controller again. Now, could you move the presentation over by one? I don't know if anybody's using that, but yeah. So the first thing we need to do is we need to add a new import. So up here, we're going to put using Unity Engine dot scene management. So basically, what that is the way that you manage levels in your game. So the scene is what's going on at any given time, and this will give us commands that allow us to interact with what's going on in the level at this given time. So we have start and fixed update. So start's not going to be the one we want to put code in because we only want this code to happen. Remember, we're trying to respawn the character, so we only want this to happen when he touches that collider that we had there. So he's not going to touch the collider right before the game starts. And we don't want to put it in fixed update because we don't want the code running at every single frame or every time it updates. So we're actually going to create a new method. And that method is going to be called onTriggerEnter2D. So basically, what we're going to be doing is creating a method that runs when the player has been triggered with the tag that we just made. So remember that on the box collider for the boundary, we set isTrigger to true. This is where that's going to come in. So this is going to be a void function like the others, meaning it's not going to return anything. And the function the method is going to be called onTrigger. So when the player gets triggered, when the
Triggered!
Anyways, when that happens, enter 2D. So let's see, it auto-completed a bunch of stuff for me, but this is correct. So we're looking for a collision with a collider 2D. So we have the collider 2D on the boundary box, and we're looking for a time that it triggers an object by having an object touch it. So what we're gonna do is if a collision event happens, then collision dot game object dot compare tag. So this is where our kill tag comes in. We're checking if it has the tag kill on it. So compare tag, and this will evaluate to true if the tag on the player is kill. This would run anytime it connects to a 2D collider, but we only want it to run if that 2D collider gave our player the kill tag. Say it does happen. The character falls off the platform and he touches the boundary and he's given this tag. What do we want to happen? Well, we want the scene to reload. We want to restart. You know, you've lost the game. You need to start from the beginning. There's no auto saves in this game. So we're going to restart. So we'll go to we'll create a we'll use scene manager. So that's part of what we just imported into the code. So scene manager dot load scene. So we're reloading the scene that is currently going. And then the scene that we want it to load is the scene manager dot get active scene. So the scene that we want it to reload is the scene that is currently loaded. And then you have to add dot name to the end of this. I'm not actually sure why that is. Yes? Oh, my apologies. So get active scene. That's a function to get a function or method to get the active scene, and we don't. That'll probably return us a scene object, but what the load scene method is looking for is a name. So we want to get the property name from the current scene. My apologies. So now what we've done is if the player touches the boundary and the boundary gives the character the kill tag, then reload the scene. So remember, are there any questions here? Is everybody ready to move on, or everybody good? Okay. So we'll save it. Control S, or save here. We already went through this. But you have to save it. Make sure it's all saved. And then when you go back to the editor, we can now go through, and when the character falls off, bam, right back to the beginning. So there we go. We have the first bit of a game. We have the ability for the character to die and have to be sent back to the level. The character has physics. He can fall off the platform. The platform stops him from falling into the infinite abyss. And if he does, for some reason, fall into the infinite abyss, he's brought back to the beginning of the level. So that is about everything that we have prepared for tonight. There is that bonus lesson. I'm not sure. You think we have time for that? It's a little. Okay. Well, this will be pretty quick. And you don't have to follow this if you don't want to. We're going to be going over this in another workshop. But basically, we want a we want to see what the character might look like if we were using an actual character image instead of just a box. So we're gonna just look on Google Images, character sprite. And ideally, we want something that has a transparent background. See, this doesn't have a transparent background, so we don't really want to use that. Let me see what I can find here. Yeah, that's probably a good idea. I'm not sure if that's a transparent background or if that's I think that's fake because it's already in the preview. Well, we'll give it a shot. If it doesn't work out, then it doesn't work out. It's no big deal. So let's just save this image to wherever you want to save it, wherever you can quickly find it. I'm gonna just throw it on the desktop here. So we've now saved our image, and what we want to do is this is going to be a sprite, right? So we're going to put we're going to put the, let's see, let's see, where have I saved it? Okay, here it is on my desktop right here. So we're just gonna move it right on into the sprites folder here. And no, it does not look like this has a transparent background, but that is okay. It'll be exactly the same. It'll just look a little more cubey than I was hoping. But so what you got to do is, again, if you want something in your game, you have to move it from the assets folder into the hierarchy. So now we have that. But he is huge. So what we want to do is we want to use the scale tool to make it a little bit smaller. Let's see, and then we'll use the move tool, move him over here. But this is now our character. So like I said, you don't have to follow along with this. We're gonna cover this again in another workshop. But what I'm gonna quickly do is I'm actually gonna get rid of our player here because we have a new player now. So to get rid of a character that is in your game, you just delete it from the hierarchy. So now this is our new character, and remember, we need to add a box collider so that he doesn't fall through the platform, and then we also need a rigid body so that he has physics, and we will change the rigid body to continuous so that there's smooth movement. If you've ever taken statistics, continuous stands for numbers that don't line up one-to-one with integers. So basically, your decimal points and all of that. That is continuous. Discrete would just be integers. So now we have that, and remember, we need to give it a script in order to move. So we'll give our new sprite the player controller script that we've made. So when we start it up, now here we have this guy as our character, and he does all the same stuff and responds right at the beginning. And there we go. We'll go into more in depth with this later. We'll probably do part of a workshop in the near future on like how to do simple animations to make your character look like he's walking, and we'll add some what do you call hazards into the stage, and we'll give him the ability to jump, and it'll be really cool. So thank you guys for coming, and I hope we see you the next time. And if you want to review anything that we've gone over tonight, we will have it posted on our YouTube channel by the weekend. And if you don't know what our YouTube channel is, could somebody pass around a sign-in sheet, please? Here, I'll give you some paper.
It's been put in the Discord as well.
We'll send the video out to everybody on our mailing list, and you can join our mailing list by giving us your email on the sign-in there. I think I've seen a lot of you around, so I'm sure a lot of you are already on our mailing list. But yeah, thank you guys for coming. We really appreciate it, and I hope you had a good time. Are there any questions before we close out? Great. Thanks, guys. And thank you, everybody who is watching over the stream. Like I said, you can get the full recap of this video on YouTube by the weekend, and we hope that maybe you'll be able to come in person to see the next one, because we are going to be providing live support, and tonight we had some, free drinks and stuff for whoever showed up. But thank you for coming, and thank you, everybody, and good night.